Hey, hello and welcome to our session Quo Vadis Modeling. This is a sponsor talk. We don't have contracts here. You don't have to sign something. We will not sell something. It's just about sharing our idea where we see modeling in the future. So before we start, Eclipse is a platform where modeling is very popular. But actually, it's not only Eclipse modeling. It's a general modeling community that is there, and it's because of that, it's by intention that we three are staying here, because all of us have a little bit of history about modeling. So first, for me, I'm Holger. I used to work for Itemis for at least 10 years, and I'm working on the Xtext project and Extend, so it's textual modeling. Then we have
Alexander, hello. I also work for Itemis in Lünen. I'm the project lead of the graphical editing framework project, and even while it's not literally a modeling project, it's somehow affiliated. So in the older days, you could find GEF under the modeling section if you download something from the simultaneous release sites. And internally, I've done a lot of modeling tools as well for customers using graphical notations, but also textual. So I also have quite a track record there, as has
Bernd. I'm also working for Itemis in Stuttgart. I have also some history with modeling, started about 10 years ago with textual modeling based on Xtext, and then in the last 6 to 7 years switched to a different modeling platform, which we'll see later.
Okay, now you know where we are. So first, who models? From the past, we learned that we wanted to model because we need some kind of extraction, because in earlier days the frameworks were a little bit loud in the meaning of you have to produce a lot of code and configuration, maybe in different languages, and a bunch of boilerplate. So we want to have more abstraction to generate that kind of messy code. And in the last years, developers and software architects were the one who actually models. And we started at the beginning with UML, and we raped UML a bit to express ourselves in some kind of DSL, because we are used that fancy stereotypes and tag values was really a pain in the ass, especially with the OCL. And then we started to rethink, we want to go the way with domain-specific languages. And talking about domain-specific languages, there are two different ways we want to model. So first of all, the architect likes boxes and lines to draw architecture, graphics, and the software developer is more or less happy with text, because it can be versionized with the code that he actually writes, so it doesn't feel really strange. And both of them are happy with an IDE, both of them are happy with some kind of version control system. They're happy with text, with graphics, and that's pretty good. At the beginning in Eclipse, we had that the Itemis framework. Some people claim it's the Eclipse modeling framework, but actually it's the Itemis framework. And everything is based on that. So we have that fork, we have the graphical guys, we have the textual guys, and we'll start with the graphical stuff. So at the beginning, there was GMF. Who knows that? A lot of people. It's still used. There is GMF runtime that combines EMF with GEF, the earlier version of GEF, GEF3, together, and you can build graphical editors. And because that was not that easy, people tend to put a more abstraction on it. So that is GMF tooling. Actually, that's dead nowadays. Maybe people are still using that, but hopefully not. And you may recognize this involves a lot of models, and at the end you will end up with something that works, but it's really ugly. And you have to do a lot to make that fancy and nice, and yeah, was not that good. So then at the past we had graffiti. Who knows graffiti? Not so many. It was started by SAP. It looks nicer, and there were no models. It's just an API to hide EMF and all that stuff behind. It's based on EMF and based on the old version of GEF. Same story. So after that, people tend to claim it's complicated to create graphical editors with graffiti. because of that, we need another abstraction layer, it's Spray. So Spray actually was nearly the same than GMF tooling, but with a textual DSL to describe some kind of editors. Okay, it's that as well. Then we have Sirius. Sirius is, at this conference, very popular. Sirius is based on GMF runtime, that is based on the old version of Jeff in combination with EMF. So same story, another abstraction. But Sirius is working a little bit different. It's interpreting the model that is created in Sirius. But at the end, Siri, at the end, at the end, you have something where you can create graphical editors with a very nice way. So that actually works, and it's great for graphical editors in the Eclipse ecosystem. On the other hand, we have the textual stuff. I claim there is only one thing that you should use for textual modeling, that's Xtext. Who knows Xtext? Hopefully all of you, yeah. And looking at graphical editing, looking at textual editing, it feels strange to bring both together. Because of that, people claim we want to just have viewers. And there are nice viewers out there. This is the diagram view of FX diagram, a small project. And it can nicely show the state of a model that is on the left-hand side. And it's pretty cool. It's not an editor, just a viewer. But nowadays, we have sessions all around that try to combine graphical and textual models again. So we have that join after the fork. And I just want to wrap up what's going on there. So there were many attempts. It's not only one. So starting from 2012, people started to do that with GMF. I started to do that, and it did not really work out. Then people tried to do that with Graffiti, same story. Nowadays, people try to do that with Sirius. Seems to work better, but it's a lot of code that you have to write to make them work. And people do that with GEF, because the newer version of GEF has a nicer API to do that. But at the end, it's always the same problem. So we have the same problem. To wrap up what the problem is about, you have to understand what a graphical editor is different as a textual editor. And textual editor includes a parser. So what you do is you edit the text, and the parser will pick that up and create the AST. So you never interact directly with the AST. You interact with the syntax. In a graphical editor, that's completely different. You create events. That events will get executed on the AST. The AST will get changed, and then the representation of the AST will get shown. So you can call that graphical editor, or you can call it a projectional editor. You will hear about the last thing in the next minutes. The problem is you cannot bring this both together, because it's a completely different approach. With a textual modeling, you can create models that are actually not valid in the meaning of the grammar and the parser, and you end up with something that is broken. I mean, the text is still serializable because it's text, but if you have a graphical editor that has parts that are edited in a textual way, you have to merge to sync that stuff, and that's pretty a challenge. And that is why you have to write a lot of code to make that happen. And we had to change Xtext a bit to make that happen. But at the end, it's very, very complicated. But at the end, there is a question, whoever want that? And I will hand over to Bernd. Thanks.
Okay. So as Holger just mentioned, we started all out by addressing essentially developer-oriented people with developer-oriented workflows. But over the time, in many of the projects I've been involved with, the target audience was no longer really developers. We moved further along, and then the target audience were business analysts and systems engineers. And these system engineers and business analysts, they were not using the IDEs that we are knowing. They used UML tools on the one hand side. They used requirement engineering tools. They're using Words and Excel and all of these things. So they are already dealing with a lot of different representations. And their prime challenge is to integrate all of these different notations and to make these different notations work on the same integrated model, maybe representing different states of the model in different notations, depending on who's the target audience. So I'll show you a few of the projects that we've been doing in the recent years and how they evolved. So initially we started out by people who just wanted to write human readable code. So imagine here you have a variable of type patient, and on this patient you want to invoke a method. And the code should be reviewed by doctors later on. So they need to be able to read it like that. And then there are business analysts who want to write their logic in decision tables like here, and then address or say how the syntax should look like on top of that. Or we had systems engineers, and these systems engineers, they had to bring together graphics and text. So here we have integrated graphics and really editable graphics along with textual representation. Then we were dealing with physicists, for example, and biologists, and they wanted to use math inside their program code. They're still engineers. They still have a relatively developer-oriented workflow, but they don't want to be stuck with text. So here is an example from a high-performance computing domain where they wanted to model matrices and have matrix operations, and then have different code generators that optimize the code depending on the target that it should be executed. Or that is an example from a telecom domain where they have huge price tables and they want to model the price tables and see how these different price tables work out, and then simulate these things directly inside their IDE, play around with it similar to Excel, where you can just hack in a few numbers, execute the stuff, see how it changes, debug the code in the sense that you're simulating the stuff. Or here is again something from the medical domain. It seems that doctors are relatively comfortable with decision trees, so they can follow a path along that, they can input values to that, and then see how the system should behave. Another example here is from essentially security modeling, where we want to see how a system can be attacked, what are attack scenarios, how would that impact my system. So far, many of these things have been done in Excel, but the problem is that Excel is very limited from its notational flexibility. What they needed is, on the one hand side, these Excel notations, on the other hand, graphical notations where they can model their system similar to UML, and then all of these things need to be combined and executed. Or here's something that looks even more like Excel. There we had customers who had to describe essentially events on a timeline and then model actions on that timeline. And so everything that you see in here, whether the border is filled or whether the border is open, whether it's red or whether it's black, that has semantic meaning. And so far, what they've done is they modeled all of that stuff in Excel. They handed it over to the programmers. They need to understand the notations. They need to redo all of that in code, in C. Then it went back to the actual domain analysts, and they had to understand the C code again that was modeled there. So that didn't really work out. And here the last example is from the insurance domain. This is essentially part of an insurance contract, which again is generated Java or C out of it. Right? So it looks like Word, it feels like Word in many cases, but they can write models here, they get code they can write code here, they get code completion, and all of the nice IDE features that we know as developers. Okay? All of that has been built on MPS. Why not on Eclipse Modeling? Well, the reason is that MPS is a projectional editor, and it treats also text similar to graphics. So whenever you're editing the text, you're not really editing the text, you're editing the model below, and MPS does a pretty good job in simulating essentially a textual editor. And that is very powerful. But as you've seen before, what we've done here is we've moved further along from business analysts and systems engineers to business professionals. So somebody who's modeling an insurance contract, or somebody who is modeling these timelines and events, they are much further away from regular programmers than we are. And the problem with that is that so what they need is they need these multi-notational things, but they are forced to use file systems and version control as we as developers know it, which is primarily based on files, which is primarily based on text. They have to use the diff and merge tool, they have to use these heavyweight IDEs, all of the things which are very complicated for them and things that they don't really like. And so, handing over.
And so we are hearing a few people that enforce that we need to go to the web with the stuff that we do. No, I'm just kidding. Actually, it's a mass movement. I mean, if you listen around, the rich client seems to be already made that. But why do these people claim that we want to go to the web? I think it's not because it's the web. There is a certain reason behind that. So why is the web important for these non-technical, non-developers? Well, if you listen carefully, then web in their meaning is actually a synonym. They do not want to have the burden of deploying a rich client. They want to be able to open their browser, to have it simple, accessible. They want to have a server-based persistence. They don't want to check out files and work with configuration and change management, with whole diff and merge workflows. They even want to be able to collaborate on something. So if you think of modeling insurance contracts, that's usually not something one person comes up with, but there's a team involved and they want to work with these contracts. They want to even be able to validate these things by executing stuff of that, by simulating or validating parts.
And all of them know things like Google Docs, Google spreadsheets, all of these things, right? So that's the environment they are dealing or they're working in today.
Exactly. And last but not least, the web simply is a synonym for them as something being easy to use, easy to access, with modern and easy to use UIs. But we should not misunderstand that. They are not asking for toys. They do not expect to have their tool on a smartphone and be able to work with it like a computer game. What they actually need are tools that are powerful enough to specify their complex domain logic using multiple notations, so mixing text, tables, mathematical formula, and to be able to deal with things like they know it from Excel. So I think live execution, being able to evaluate things on the fly is something that is very important to these stakeholders. So what we actually need is in parts at least as complex as the developer tools that we want, but they do not want to use IDEs like we have them. So all the technical bits need to be abstracted away. They need to be able to focus on their specific domain logic and to have powerful tools to work around that. Well, if we look at what's going on at Eclipse and at Eclipse modeling in specific, then we can see that Eclipse is somehow going to the web as well. We have seen that Orion came up some years ago. I think Che has made a lot of noise recently. And we have also seen that the modeling domain is adopting that. So I think Holger has presented Xtext in the web some 2 or 3 years ago here already. You see, 5 years ago. So the modeling community has actually been targeting going to the web as well. But are we doing the same thing again? Are we focusing on developers again with our modeling approach? I mean, developers do not seem to be in the need of such rich modeling capabilities anymore. The things are getting more slim, the languages are getting better, but the business people are actually adopting modeling. And what we see currently is actually replaying the stuff that has already been done. So what we are doing is we are creating IDEs in the web, which do not actually solve the problems that MPS, for instance, has partly solved on the rich client. But it seems the story is repeating there. So what do we want you to take away, or what do we want to take as a basis for discussion?
Just a microphone. So what should you take away? At the beginning, we started with the software developer and the software architect. We had textual models, we had graphical models, maybe in combination. And they both were happy with files. They both were happy with a version control system. They love that div merge stuff that behaves in the same way that it does for code. And they are happy with an IDE, a fat IDE like Eclipse or IDEA or whatever. But that changed.
So we moved on. We were working with business analysts and systems engineers. They needed to use multi-notational things, and they were okay with using files and version control and diff and merge and IDEs. But if they had the opportunity to choose, most of them would have preferred something that is much more lightweight.
And now, as we have the web, we have the possibility to make modeling available for a broader class of business professionals, which need rich modeling capabilities, so mixed notations, but who also want to have a shared repository on which to work on, to collaborate. They want to abstract away from text files and configuration management to a repository. They want to be able to have a rich set of features like we know it from our developer tooling, but based on their domain-specific things. So we think that's where modeling is going, and it has to go in order to be successful in the next, I don't know how long is modeling around at Eclipse, 15 years. So for the next 15, I think we have to bridge the gap from building something for developers to building something for domain experts and enabling them to use all of the nice technology that we are producing. If you share that thought, then please join our discussion. If you're not, then please do as well, because we are interested in getting opinions on that. So that's our vision of where modeling is going and should be going in the next years, and we will be working on that as well.
And where we currently still a lack of tooling, right? And so we would also be interested who's seeing a lack of tooling there as well, and who would like to participate in creating such a tooling maybe.
And if you agree that creating an IDE in the web is not the answer to solve that, because you're still dealing with files, there is no repository, and there were many, many attempts to solve that problem, to store models in a database. That's doable for things that end up in EMF, but for textual models, it's very, very complicated to do that. There were attempts, all of them are dead nowadays. And yeah, the problem still exists, and from my point of view, or from our point of view, it cannot be solved with the stuff that we currently have at Eclipse, and even the general modeling stuff that is out there, including MPS, is not solving our problem. Any questions about that or thoughts?
Comments?
Yes, they started doing something like that, but it's very, very slow, and also from my perspective, it's repeating some of the same mistakes Eclipse does or did as well, right? So we have a heavyweight IDE there, and just porting something that already exists to the web, that won't solve our problem. So fundamentally, we have to change from a file-based approach to something that stores data on the backend. We have to move from something that versions with Git or SVN or whatever tool you're using to something that is much more like Google Docs. So something that does OT or TRDP or whatever you want to call that. Something where you have permissions, for example, first in a backend system where experts are working on, then you typically have permissions where only a few people can see or edit things, which is very hard to do in a textual world as well. We are checking out entire files. So from that perspective, even just porting NPS as it is today to the web wouldn't solve the problem.
Other ideas, questions?
Is there a time frame when this can be realized? That okay, it's not we don't have this yet. We did not solve that so far. It will go in this direction. What is the time frame until this gets real?
We are currently working on a prototype for something like that, just to see what it means to do all of these things and to find out what is necessary for that. I think by end of the year we will have something that we can show to make that a real usable tool, product, whatever you want to call that. That will take whatever, yet another year, I'd say. But I mean, from my perspective, it's not so much about talking now about products or tools or whatever. It's more about getting feedback, getting interest in that, and understanding if we are the only ones who are seeing that direction, or others are thinking a similar direction, and then maybe we can join forces.
I share this vision completely, but customers are really looking for it. We are also looking for DevOps, relatively strongly linked to work. So the kind of system control and stuff
So again, I think the data in the end will be stored in some kind of backend system, which is more like a database. Nevertheless, we will have versions there, and we will have to have something like continuous integration, where whenever somebody commits something into the database, we run a bunch of tests, we maybe run a bunch of generators, maybe we run interpreters, and from there on, the entire continuous integration chain and DevOps chain can run as we know it. And that's something actually we've already prototyped, or what we've done with de-facto.
Are you aware of a project called OpenMDB by NASA JPL?
Heard about it.
You should check it out. I think.
Yeah.
Because it covers a lot of the things that you are just about to develop.
Yeah.
Could you talk a little bit more about that project, or just you said I did not hear about that?
Well, to my knowledge, and maybe you will correct me if I'm wrong, it's essentially the backend system for it. So it's essentially a database which is able to deal with models, big models, execute analysis on that stuff. So it's more, from my perspective, it's not so much about the front end, but it's more about the analysis and the powerful backends you need for that in order to do the live execution and analysis and all of these things.
Almost. So there is a big part of it is related to the backend. That is called actually MMS, that's Model Management System. But they have a web-based front end for the interacting with the contents of the repository. It's based on Alfresco. So it's a document-oriented paradigm for collaboration, and they also have these on-the-fly, collaboration features and reviewing and things like this. And they also have an integration with a commercial modeling tool called Magic Draw.
Yeah.
So there is a plugin called MDK for Magic Draw, which integrates with the backend, and you can use it for collaboration as well.
Yes, but at least to my knowledge, what they're not addressing is the seamless integration of these different notations, which from our perspective, what we've seen with our customers is a very key feature. So what they have was Camille, I think is what they're using essentially with Magic Draw, right? It's based on Camille.
The whole ecosystem and what they are doing is very much XML centric.
Exactly. So it's primarily graphics with some text mixed in.
Yeah, but the backend and all the functionality is already there. So it's just that they didn't develop it in this domain-specific language.
Does that approach address collaboration?
Yeah, absolutely.
Yeah.
It's one of the central things.
Cool.
Here we are at the developer conference, and so far we see specifications being thrown over the fence to a team of IT specialists to interpret and implement specifications. Is this approach rendering all the programmers obsolete, or what's your take on this?
No, obviously not. It's just that I think what we'll see in the future is that we will get people who are much more focusing on optimizing backends, on focusing on technology, porting generators, porting all of these things, and then we will have domain experts who will take their part, their share in software development much further than what they do today. So the example you've seen here in that Word document, or Word-like document, that's an actual insurance contract that so far was written in Word, in pseudocode, was essentially handed over to India. It was written actually in German. It's handed over to India, and the pseudocode is so formal that the Indian guys can actually interpret that and write C code out of it. And that is something which will go away. That's just essentially a human code generator. That doesn't make any sense whatsoever. So what we've implemented in that project is that the guys, in this case on the Indian side, are still focusing on all of the technology, all of the backend systems, maintaining all of the DevOps scenarios that we have there as well, running all of the integration tests, helping people with debugging, essentially keeping the whole entire system running, and also moving it from one technology to another technology as time evolves. And then we have the actual business. And so far, one of the big problems in my experience for many of these companies is that as technologies evolves, they have to redo a lot of their code again and again. Right? So they're doing requirement engineering again because they forgot what the last software could already do. They need to find out again what is the business about and just re-implement these things over and over again. And what we're trying to implement with that is that we split actually technology and the actual behavior so that both can evolve on their own and then through code generators or interpreters or whatever, move them again together.
So if you enable the business professionals, at least that's what we think, then you can have clearer interfaces. And the programmers don't have to be domain experts, and the domain experts need to dig into source code, which they don't want to do. So enhancing the business professionals to capture and validate their complex business logic without involving the IT, I think, is something that can also help the IT in actually concentrating on what they are wanting and what they need to do, namely to deal with the technical progress of the infrastructure.
I mean, the idea to enable a business professional to model the system or to model software is a very old one, but it never worked out so far. And it has to in the future.
Okay.
Okay. If there are no questions anymore, whenever something pops up, we're at the booth in front of the theater. So thank you for listening.